Hello, grade 10 math students. You have made it to the end of Unit 1. Now, this Unit 7 summative activity is a little bit weird. I'm going to be honest with you. When I saw it, remember this is my first time through the course as well, I was like, this is a little strange. But now that I've done it, and I'm like, oh, okay, yeah, it actually does pull it all together, and it is actually kind of a cool little assignment. But I'm going to give you a little bit of help because I don't want you to get frustrated, and I'll give you a little bit of tips to make your life a little bit easier, okay? First thing you need to know is you are going to be asked to either do this on paper or digitally. Now, if you choose the paper, it is what we call letter paper. It is not regular size. It is longer. Like regular size paper is this big and letter is longer, okay? So if you don't have any of this size paper at home, I don't know how nicely it's going to print for you. If you want a copy of this, of the paper version of it, you can ask your teachers when you're at your support sessions, and they hopefully can print out a letter copy, a legal copy for you. I have seen some students able to shrink it and print it on regular paper. Now, I'm not sure if your printer can do that or not, but here's the good news. You actually don't even need that paper. You could do this on just regular paper, and you could literally just write out the questions, because what it actually is it gives you these 4 blank templates, right? So there's 4 files, like 4 pages. So it's 2 pages of data, right? So you got some instructions at the top, and then you've got these different items that you can cut out. Now, literally, like with scissors and tape, you can cut them out, pages 1 and pages 2. So when you do print it, make sure you print only one side per page. So you can cut these different things that are on page 1 and page 2 out, and then physically tape them onto the blank template pages. Or you could do it in like Google Docs, Microsoft Word, whatever you have. So when you go and you get to this section here, you read everything very, very, very carefully. There she gives you some tips, like look at this. She keeps the tables for area and perimeter together. Oh, that's a good tip to have. For the graphs, the independent variable is always the position number, right? So we're going to have to remember some of these different things. So your task is to download the assignment. So if you're going to do it in Google Docs or Microsoft Word, you have to make what's called the RTF. RTF stands for Rich Text File. So basically, it's like a computer editable file. PDFs are not editable unless you have PDF software, which it's expensive. Most people don't have that. You might have it on your computer. I don't know. All right, so I'm just going to minimize myself here and give you a little bit of help. So if you download it, notice how it goes up here into your downloads folder. Okay, so now if you click it, it opens. I've got a couple copies open here in Microsoft Word because I've been practicing it. So here is the instructions. Your task is to copy and paste each one of these and put them in the right spot. So you're basically moving these things into these different cells. And there's going to be a lot of empty cells that then you're going to use either Microsoft Word or a pencil if you're doing it on paper. And again, you can just recreate this on a blank piece of paper. You can do this all by hand if you want. It doesn't really matter. I'm not marking it so much for, how you did it. It's a matter of, can you make the connections? The whole point of this is, can you make the connections? So that's why it says there's 2 ways you can print it, and then you can literally cut them out, tape them, label them, or you can just do the digital. So I'm just going to give you a little bit of help here. Now, secret building challenge, I would call that number 1. I would call that number 2. I got to say enable editing here. Sorry, I got to enable my editing, so I'm in editing mode. So you're given 3 of them, but notice you're given 4 pattern rule 1, pattern rule 2, pattern rule 3, and pattern rule 4. So I'm sure you can figure that out. You got to write one, right? Like you're going to end up writing one of these secret pattern building challenges yourself, right? Now, to make your life easy, I would just make this number 1. I'd make this number 2. I'd make this number 3, and then I would make number 4 the one that you write yourself, right? Like keep it simple. So let's take this one, and we're literally going to drag it, and notice how I get the 4-sided cursor, and it's kind of weird in Microsoft Word. Like you kind of drag it down a little bit, and it just goes down a little bit. You got to keep going down a little bit like this. I know it's a little bit weird. You got to just keep going down, keep going down, keep doing that. So where I want to put it is in this pattern challenge, right? So I want to put it, and see how the little anchor goes in that box? I want to put it right there, right? So that's going to be my pattern challenge. So I'm going to read it. Secret pattern building challenge. Build the first 3 positions for this rule. Number of tiles is the area of the rectangle whose length is the same as the position number. Width is 2 times the position number. Okay, now again, if you're doing this on paper, you could just draw this out what algebra tiles would look like. If you're doing it on the computer, you know that we learned this website straight back at the beginning, and we learned this website here, how to use algebra tiles. Yay! You know how to do this. And there's a little website here to the Math-Thegon website. Well, I've already gone over to the Math-Thegon website, and I've already, just to save time, I've already literally copied it over. So yes, I'm giving you the answer for the first part of number 1. And how did I do this? Remember, you just go over here and you just drag the little tiles over. Oh, my recorder is in the way here. Okay, I'll move my recorder over. Okay, so say I wanted a number 1, I literally just go here and I drag a number 1, right? So you're going to have to make your own. When you want to put a text box on, it's down here. Make them close because you are going to need them close, right? So if I had a relation where it was just 1 to 1, position 1 was just 1, that's what it would look like, right? But that's not what it is, so I'm going to actually delete that because it says my secret rule. Remember, it said here. It said, and I'm doing number 1, the length is the same as the position number. The width is 2 times the position number. Okay, so if I want to do it like this, here it is. The length is the position number, so number 1 is 1 tall. The width is 2 times it. So 1 is going to have 2 tiles. 2 high, 4 wide, because it's 2 times. Number 3 high, and it's going to be 2 times. So I could do a 6 across. 1, 2, 3, 4, 5, 6, right? So I did this already in algebra tiles, and then I went to my screen capture software, and I took a screen capture of it. And if you don't know how to do that, I use the snip tool. This comes on all Windows computers. Your Chromebook is a little different. You can figure it out. Just Google how to do a screen capture, right? And then, oh, there it is. So there's my screen capture that I'm going to put now, because the second one says, what is the physical model? So this is like, how would you draw it out with algebra tiles? And again, I'm going to make it a little smaller because I'm going to try to fit everything on 1 page. I'm going to suck up the extra blank lines by just putting my cursor there and hitting delete. So now it's asking me, like, what is my pattern rule? So these are examples of the pattern rules. Okay, so this is, again, like your math. Like, how would you do the math? That's your pattern rule. Well, let's see if I have a pattern rule that basically says that the area is the length is the same as the position number, and the width is 2 times the position number. Position number times the position number plus 2. No, that's not right. Position numbers, no. 2 times, no. No, okay, so they didn't give me one of these already. So, oh, that means I have to write it in. Like sometimes you're going to be able to just take this and drag it down. All right, big problem in this though, and I don't know who made this assignment, but this one doesn't work at all. Okay, so just ditch that one and forget it was even there, because that one, I tried it and I'm like, that doesn't even work on any of them. Maybe they're trying to really make you think, and they planted a bad one in there. I don't know. And these two don't necessarily go together. Okay, these are all independent, right? They just happen to be down as part of the table. So again, sometimes the tiles are already done for you. Ooh. Sometimes the graphs are done for you. Sometimes you're going to have to do your own graphs, right? And that's what you're doing. You're going to drag this one to the second one. You're going to drag this one to the third one, et cetera, et cetera. Okay, so back to our work here. I've helped you with the first one. I've helped you with the tile pattern. Okay, so what's the pattern rule going to be? All right, well, we know panic when you see pattern rule. What this basically means is, what is the math equation that is happening here? Well, again, go back to the secret pattern. The length is the same as the position number. The width is 2 times the position number. So I'm going to change my font color to blue, and I'm going to make it a little bit bigger just so that you can see that this is me typing it. So the area of this secret pattern is clearly the position number times the position number, I'm not spelling that right, position, there we go, number times 2. Now, if you want to put this in brackets so you understand, like one side is length and one side is width, I think that kind of makes sense, right? Because now we're going to try to see if we got that right. The position number is number 1. 1 times 2 would be 2. Is the area of the first one 2? Yes, it is. Right? And if you wanted to keep track, you could even put a little table in right now. You go insert table, and you're like, okay, if this was my position number, and this was my area, for position 1, I have an area of 2, right? That makes sense. That makes sense. That looks good. All right, now let's try it for number 2. So for position number 2, let's put it in. Let's do the math. Well, first of all, I can just count up the area. 1, 2, 3, 4, 5, 6, 7, 8. Okay, well, that's clearly 8. I can just count. But let's see if the math works. 2 times 2 times 2. Well, 2 times 2 is 4, times 2 is 8. Yay, that one works. Okay, let's see if number 3 works. So number 3, I can count these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so 18. I can clearly add them up, and I've got 18. I only had to do 3. But, I mean, I could make this table of values go on because I know now the formula. Number 3. So if I said 3 times 2. Well, 3 times 2 is 6, times 3 is 18. Yay, this works. This works. Now, hold on. Maybe I already have one of these table of values. Let's go look, see if they gave me one. Do I have a table of values that is basically 1, 2, 2, 8, 3, 18? Let's have a look. Aha! Look, I didn't even have to do that. I can just drag this table of values because they gave me the table of values. Oh, so nice. So I can actually ditch my own table of values. I didn't actually need it. Right-click, delete table. Can I delete the table? That might be another whole story. Delete cells, delete entire column. Right-click, delete rows. There might be a faster way to do this. Normally you could say delete table, but we'll just do it this way. Delete rows and delete rows. Okay, so we didn't actually even need to do that, but I like to do that just so that I'm organized with it. And remember, I told you there was a little hint. She kept her area and her perimeter together. Well, let's just double check. 1, 2, 3, 4, 5, 6. For position 1, I can count 6 sides. For position 2, I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 2 would be 12. So let's go see if I can find a 1, 6, 2, 12 table. Let's go see if I can find a 1, 6, 2, 12 table. Of course, I've already told you she's kept them together. All right, so we're going to drag that table all the way down, and we're going to put it in here. Okay, so now we have to do the graph. Okay, well, 1, 2, 2, 8. Well, Mrs. Mallinson has told us Desmos is amazing. And if you don't know how to use Desmos, let me just start it again. So you would go to decimals, and then you would say, I'm trying to put on a table, and then you would say, I want a 1, 2, 2, 8 in my table, a 3, 18. Oh, and they've even given me the other one in the table they provided, 4, 32. Okay, so there's my dots. But that looks kind of weird. I don't want to have just dots. So you go to this line here, add regression. This is not a linear regression because it has a 2 as our biggest function. It would be when we are multiplying x times x is really like x squared, right? So we have to choose quadratic regression. And voila! So there's actually what it looks like. Now we only need half of it, but Desmos gives us the whole thing. So that's kind of cool. And we would screen capture it, right? And we would paste it in. Oh, but really, we should look and see. Maybe they gave us one. Maybe did they give us one with 1, 2, 2, 8? Let's have a look. Look at the tracks. Is this 1, 2, 2, 8, 3? Oh my gosh, it's right here. I didn't even have to do that work. I will have to do it for the other ones, right? And if you don't know how to do the linear regression or if you want a straight line, it's linear. If you want a curvy line, it's quadratic, right? So, but you should have learned that in the unit. So we can actually just grab this one. Yay! They're so nice. I'm giving you so much help on this first one, okay? So there's my graph for the first one. And again, I'm going to make it smaller because it doesn't need to be big. I'm going to suck up any extra lines that are in there. And now I have to write the word equation. Now, when you write word equations, that's like, say someone doesn't know what you're trying to do, and you're just trying to explain what you're doing it in English, right? So the area is I'm going to write it in blue. All right, where's my blue? Blue. Because it just looks, I can tell then that this is my work versus the worksheet work. The area is the position number times the position number. We could actually say the position number squared times 2. Right? So there's a couple ways that you can do this. You can also say the position number squared times 2 would be another way if you wanted to write that. I mean, there's more than one answer here. You could say, or area equals position number squared. Now, how you do squared when we write it is you put that little weird, it's called a caret, position number squared, and we'd normally say 2 times, right? 2 times versus times 2. 2 times the position number squared, right? So again, 3 squared is 9 times 2 is 18. See, it works. So there's more than one way to do this, but because we have the exponent 2, so again, you can write it that way, or we can say, or we can say the area is 2 times the position number squared, right? Okay, so there's more than one answer the point is that you're making the connection here, the connection. Now, let's just have a quick think about the first and second differences. Between 2 and 8, that's 6. Between 8 and 8 and 18, that's 10. Between 18 and 32, that's 14. So we had a 6, a 10, and a 14. Oh, well, what do we know about 6, 10, and 14? There's 4 between them. So, I mean, if you were really wanting to make really good notes, you could even make little side notes over here. And again, I'm going to just do it in blue. The first differences are not constant, but the second differences are the same. That equals, it's a quadratic equation. and will form a parabola shape. And if I could spell parabola right there, I just got to type it right. All right. So now I think I've given you way more help than what's needed, right? Obviously, 1 and 6, 2 and 12. Let's see if we have a straight line. 1 and 6, 2 and 12. Oh, look at this. 1 and 6, 2 and 12. Okay, so I'm helping you with the first one because like I said, I found this assignment a little bit weird. Oh, I lost it. Come on, computer. All right, let's drop it there for a minute. Click off. I got some strange thing happening. There we go. Okay, let's kick me there. Oh, another way to do this is you can actually go Control X, so it cuts it out for a minute, and then put it where you want it, and go Control V. That's another way to do it. All right, I'm gonna make it smaller, and obviously, oh, I have to also write my pattern rule, obviously, for perimeter too. We're not just doing one, right? The perimeter. Now let's look at the pattern here. 1, 6, 2, 12, 3, 18, 4, 24. Well, I don't think that takes a genius to figure out. It's basically whatever this number is times 6, right? 1 times 6 is 6, 2 times 6 is 12, 3 times 6 is 18, 4 times 6 is 24. Oh, and look at the differences here. 6 to 12 is 6, 12 to 18 is 6, 18 to 24 is 6. Oh, so cool. I can see the relationships. I can see the patterns, right? The first difference is constant. Therefore, it is a linear relationship, right? So our perimeter is literally just our position number times 6. Right? That's what it is. It's like, don't overthink it. Then you're going to write it in a way that a person who's never taken algebra in their life, but maybe they know what perimeter means, right? I should make it a little bit bigger. I just think it looks better. Okay, so the perimeter is the position number times 6. Right? You're just writing it in English. Then you have to do the proof, and I'm not going to do the proof for you, so you have to be able to figure out the proof. And again, try to get it so that it's on one page. It might be easier for you, even if you have to just delete some of this later. How did you use the key features of representations of these two groups? Well, explain what you did. I read the secret pattern building rule. I drew out using algebra tiles. I figured out what the pattern rule would be. How do you know your answers are correct? Well, because a quadratic has an exponent of 2, the highest exponent. A linear would have the highest exponent of 1. Notice there's no exponents here, which is an implied exponent of 1, right? And so I know that that's going to be a linear relationship. I know that my independent variable is always the position number, because it told us that. So I could find the graphs. I could literally match up the tile positions with the table of values that already existed. And remember, they're not going to always exist. Okay, so when you go to do pattern 2, and I don't know why it won't let me suck up any more spaces there, but you can go like this and say go up there. Okay, so just play with it. It doesn't really matter if it's on one page or not, but it just looks nice. So you're going to write some sentences here. This is what you're getting your marks for. Explanation. Use your proper mathematical vocabulary. I'm looking for words like quadratic, linear, parabola, independent variable, exponents, first differences, second differences. Like, you've written down a little bit of the work up here already. You could have also put that down here. But the point is that you're proving to me that you know that all of this is relating to this secret pattern. Then you're going to do the second secret pattern, right? You're going to, again, just take my advice and just go and grab the second secret pattern, Control X. Oh, it doesn't want me to do Control X here. I think because it's got this little crazy anchor thing. I'm not really sure how they did that, but we're going to drag it down or cut and paste it out. Doesn't matter to me if you cut and paste it out. Microsoft Word is sometimes a little bit fussy, but don't worry. Okay, so keep going. There's pattern 1. That's funny how pattern 1 went on the new page. That's okay. No, I don't want to put you there. I want to put you lower. Keep going, computer. Keep going. There you go. There you go. It's like a magic sweet spot. See, because it keeps on thinking, oh, do you want to drop it here? Do you want to drop it here? No. And I didn't want to go to number 3. I want to go to number 2. Hello. Back up. Back up to number 2. Back up. There we go. Here's where I want to drop it. And I put my anchor right there. Okay? So now you are going to have to figure out, maybe on this next one, they've given you the physical model. Maybe they've given you the pattern rule. Maybe they've given you table of values and graphs, right? And then on pattern number 3, you're going to drag that one down here. So, like I said, don't get frustrated with this one. It's kind of cool when it gets all done. I've helped you quite a bit. I'm not totally done because you have to do this section, but I've helped you quite a bit. So good luck. You got this.